Hello guys, before we begin, let's introduce ourselves. My name is Aini Arvina and there are my colleagues Denny and Lara. We will present about our final project in Bangkit Academy and we take issue about face expression recognition. Okay, let's start. For the dataset, we use facial expression recognition FER 2013 and the reasons why we choose this dataset because non-verbal communication is the things important in communication, and the facial expression we can look their feelings, people feelings, and it's so interested and maybe will be useful if we create machine learning system can learn about expressions of humans with this dataset, and maybe system can be more accurate to predict face expression than humans. The dataset consists of 7 facial expressions, which are angry, disgust, fear, happy, neutral, sad, and surprised. And you can see the examples of image, but some of image of the class look similar with the other class. You can see maybe in the second class, you can see it looks similar like the sixth class. And you can see the diagram of distribution of data, and you can see that the data sets have an imbalanced data. Okay, for workflow, we start from the data set and we create the baseline of model, and then we improve the model, and if the model is okay, we convert the model to the TF flat, and then we implementation in application development in Android. Okay, next then.
Okay, here we can see the baseline model. So at the left picture, we can see the architecture of the model. We use 3 convolution and max pooling pairs for the baseline model, and we trained with Adam as the optimizer. We trained the model for 25 epochs, and we can see at the right graphs that there is no improvements after around 10 epochs. Okay, next. And then from the baseline model, we do prediction from our data set and see if there is any misclassification in the prediction. And here are 4 examples of the misclassified images. We can look at the first one. The images are labeled neutral, but the model predicted it as happy. At the second one, it is labeled happy, but the prediction is neutral. At the third one, we can see clearly that the girl is smiling, but somehow the label is neutral and the prediction actually is happy. At the fourth image, we can see that the label is fear and the prediction is neutral. Well, from these 4 examples, somehow we can see that there are kind of similarities between dataset and between classes, I mean, and so that there might be ambiguities between classes, and also there might be mislabeled images on the dataset. Okay, next. So those 2 conditions can be clearly be seen on the confusion matrix, which we can see, for example, the 4th class is diluted to other classes. That might represent that class 4 may be ambiguous rather than others classes. And next to the performance of the model, at the right side, you can see that the accuracy of the model is 51%. And because this is an imbalanced data set, and it might be more proper to use F1 score rather than accuracy. And the F1 score is 47%. Okay, next. So there are 2 improvements that we can do from our baseline model. So looking from the problems that we have seen before, the first one, we are trying to reduce the ambiguity in the data set. We reduce the ambiguity by reducing the 7 facial expression classes to be 6 facial expressions. We do this by removing the neutral class of the facial expressions. Well, what we have done is justified by Ekman, 1977, which he stated that basic facial expressions consist of 6 facial expressions, which are happy, sad, surprise, fear, disgust, and also anger. And then the second improvement that we are going to do is we are going to increase the image size of the input image. So sorry, the original image size is 48 by 48, but it cannot fit into a deeper model. So that's why we increase the image size to 150 by 150. Then we can try to apply transfer learning to the data set. Okay, next. So here is the improved model. And see on the left picture, we use Inception V3 as the model, which have been trained on ImageNet. We did 2 training. The first one is using Adam as optimizer with 5 epochs, and the next one we do fine tuning with 200 trainable layers. We set 200 layers to be trainable, and then we use RMS prop as the optimizers, and we train the model for 4 epochs. Okay, next. We can see on the right side, the accuracy and also the F1 score is increased. Okay. So here is the conclusion of the improvements we have done to the baseline model. We can see that the accuracy is increased from 51% to 67%, and also the F1 score from 47% to 64%. And also we reduced the epochs of training from 13 to 9 epochs. Okay.
Okay, now if you want to demo the application, there are 3 steps that you can do. The first one, you can download the application by the link as already shown below, and then you install the application. Next, after you open the application, you can choose between 2 modes. Is it live mode or static mode? And you can see your expression results. Okay, now if you want to replicate the code, you can get clone. You can get the clone by the link below, github.com/ayuniarvina/final project Bangkit. And then you can build and run the application on your device. Based on the project, we know that there are 3 implementations of this project. The first one is for event evaluation system. This project can be used to measure the enthusiasm of an event by using their face expression. The second one is for psychological research. This project can be used for psychologists to analyze facial expression to identify how humans respond towards external and internal stimuli. And then the third one is for entertaining application. This application can be used by user to train their expression, especially to give fake smile to the person you hate, or it can be used to increase interaction between friends. Okay, next. I think that's all from our group. Thank you so much for your understanding. Thank you.